All right, well, good morning, everyone. My name is Lisa Felsky, and I'm the science specialist, curriculum specialist here at Harris County Department of Ed. My main job is to provide professional development for science teachers. I do pre-K all the way to high school physics and AP classes, so got a lot of experience working with teachers at all grade levels. So you have a copy of the curriculum we're going to work through today. We have the on-the-case space science curriculum, and then we also have the additional resources. So your kids are going to be going to the Space Science Kids Day toward the end of the year. Case has talked to you about that. And so a lot of these activities they may be doing on Kids Day, like the bottle or the little, we call them bottle rockets, but we do them inside a film canister rockets. And so what I mainly wanted to do was to get you familiar with the curriculum, to do as many of the activities as we could now, because believe me, if you do it first, it makes it a whole lot easier to do once you get back and working with the kids. So for this curriculum, there's 8 different lessons that go from an overview of the solar system, talking about astronauts and going into space, and then looking into some of the science behind forces and forces in motion and space. It's kind of a broad connection for the kids, but we'll talk about them as we go. So the first activity we're not actually going to do because it's very time consuming. It's making a model of the solar system. So it tells you that you need cardboard, construction paper, tape, scissors, and what the kids are going to do is build a solar system. So the little ones, I know you have them all the way down. They may need help cutting cardboard, so that's really where you're going to be spending a lot of time. And I probably would pre-cut some of those circles for the littler ones. By second grade, they can pretty much, well, even second graders are going to have trouble cutting cardboard, but you know, the thinner the board, the easier they'll be able to do it themselves. But I probably would pre-cut a lot of those circles to make a difference. And then it has you review the planets with your students and describe their physical characteristics. And it says this is in the supplements, but I didn't get a copy unless it's over here. But what I wanted to mainly talk about, yeah, I think it's in the back of the second section. There it is. So starting on page 20 of that additional resources, it has a picture of a solar system. And then basically they're going to be making a mobile. But I'm not going to read you all the planet facts. It talks about properties of the sun, Mercury, Venus, Earth, Mars, etc. The one thing I do want to talk about that I would modify is to leave Pluto off. Okay? Because everyone's confused about poor Pluto, what's happening with Pluto. And so I think starting by not giving them misconceptions is really the best idea, to leave Pluto off. And if you want to talk about why is Pluto no longer a planet, I'm going to give you some real short information. I think it may be even on here. Pluto used to be the 9th planet, but if we're making a planetary model, let's just leave it off since it's not a planet anymore. It got downgraded to a dwarf planet, of which there are thousands of dwarf planets in our solar system, so it's really not anything special anymore. Don't really know why we called it a planet to begin with, other than I think the person who discovered it saw a moon going around it, and that's sort of an older definition of a planet, is it's a body that goes around the sun that also has its own moon. But that's technically not the definition of a planet. That a planet has to go around the sun, they may or may not have moons, because some of them don't, but it has to clear its orbit. And that's what Pluto doesn't do. It's in a big old belt, thousands and thousands and probably millions of miles wide, of all kinds of objects. It's called the Kuiper belt. And Pluto is just a Kuiper belt object. And there's tons of stuff in its path. And so that's why we don't consider it a planet. It's only been a controversy in the sort of the popular world since it got downgraded, but they've been talking about this in science circles for 50 years, that it really shouldn't be a planet. So it just takes a while for things to happen. One thing I do like about how they have you do the model, if we go back and look at the picture on page 20, is that it shows orbits being a circle, that you sort of have a circle and the planets all dangle from it. Because that's a common misconception. Kids think that planets go around the sun in an oval shape, because we teach them that orbits are elliptical. But what they don't know is a circle is a type of ellipse. And so they think that elliptical means oval, where elliptical, you don't want to get into the definition of elliptical with 2-year-olds or second graders, but that most orbits around the sun are very close to being circular. And so that's why kids have trouble understanding seasons. Have y'all tried to talk about seasons? They have the idea that the Earth is closer to the sun in the summer than it is in the winter, but it's not. It stays pretty much the same distance away from the sun all the time. The seasons have to do with the tilt, how much sunlight is shining on the Earth. So I like the way it's organized because it lets you know that orbits of planets are circular, which is a better way to teach it. Just take out the word elliptical and call them circular, and it's a lot better. Another reason why they have that misconception is a lot of times when they see pictures of the solar system, it's from the side. And if you look at a circle from the side and like tilt it a little bit, you're seeing the inner part of the circle and it looks oval. And so that's just another way that it addresses that misconception. So I like the fact that the mobile that they're making is circular. Maybe they'll get the idea that planets go around the sun in a circle, which is closer to the truth than going around in an oval. So it's kind of hard looking at 2 books at the same time, but I don't want to miss anything. They suggest, you can just use cups to be your pattern for circles, and you can hang them from the large cardboard circle with string or thread, yarn, anything that will work. So that will actually take them quite a bit of time. And for your older kids, you could modify this and have them estimate the distance between the planets, because this just really has them all kind of wrapped around the sun. Try to have them estimate the distance between them and put them down on the ground and see. It just may make it a little more of a thinking activity for the older kids. And they may have been to the Museum of Natural Science, maybe not, but they have a model that you can, they have like brass things in the ground and you can see how far apart they are. Doesn't matter if it's accurate, it just, they want to look it up on the computer and try to do the math, that's fine, but just to have them spread it out and have them guess how far apart they are, that would be good enough. I think that would be a great activity for them. Any questions about how you would do the mobile part? Yeah, I didn't want to spend a whole lot of time just because it's pretty self-explanatory. And the second part is to have them sort of then make the connection of people going to space, and what they're supposed to do is work in teams to make a mission patch. So here's a sample of one that kids have done in previous years, where it has all the astronauts around the outside, and they can make that their names if they want. So the astronaut team name goes on the outside. Usually a mission will have a name. They probably know like Apollo or Gemini maybe. They may not know too many, but they make up their own team name, and this one happens to be Pride, and then they put what all the letters stood for. So this one says, promote success for all, respect one another, inspire others, do the right thing, excel at everything you do. So that's the name of their mission, and then they have the rocket ship and mission to success. So I'll pass this around so y'all can see. But that will also keep them busy for a while, working in teams.
Take pictures so we'll remember.
Sure, absolutely, absolutely. And so your lesson plans tell you that patch is unique, showing where the mission went, the names of the crew members, the shape of the patch. Sometimes they're circular, sometimes they're rectangular. They don't have to all have that shape. With the littler ones, you might want to talk about where do astronauts wear that mission patch, that they wear it on their gear, and that astronauts have to have special clothing to go into space. So they talk about that. They recommend that you might give them different job assignments while they're working on this mission patch. I'm on page 7 if you're following along here with me. That have one person research maybe their school history or symbols of their school that they could put into the patch. Like if their school has a mascot, they might want to put that on their patch. A secretary, someone to take notes while they're doing that. And then they also have to have the written explanation part in there, maybe to give some kids that design. Then another might be the one who does the drawing. Just a way for you to not just give a job to a group of kids and expect them to know how to organize themselves, because they don't. So, and then I would let them share their patches that they designed with other groups, let them stand up and give a presentation. That will also take some time, which I know. It's important for you to keep them busy when you have them there after school. So, okay. So the next thing we're going to do is talk about forces, and there's some activities with magnets. So we're talking about building anti-gravity inventions. It's hard to teach about somewhere that doesn't have gravity, because kids, especially the younger ones, it's just not, it's too abstract. They can't understand gravity being different than where they are. And I use this with science teachers, trying to tell them, when they try to teach the difference between weight and mass, which you're not going to be doing, not to use the example of you weigh less when you're on the moon, but you have the same mass, because kids just cannot understand that. So don't worry about trying to teach them about what gravity is and what gravity isn't, because it's really, they're not developmentally able to understand something that's that abstract. But you can show them that sometimes you can make an anti-gravity device, that gravity is what pulls things toward the center of the Earth or the center of any planetary body. The sun has gravity, that's what keeps us in an orbit around the sun. We have gravity, and that's what keeps the moon close to us. And gravity goes toward the center of objects. And other forces can counteract gravity. And one of those is magnetism, which is a force. And so you can build a device like this. I'm going to let you make one real quick, actually. So I'm going to give you a piece of string. You can pass the paper clips when you're done.
You just need one?
Yeah, you'll just need one. And I'm going to give you some tape. So we've got plenty of materials here. And what I want you to do is hook the paper clip to the top of the string and then tape the other part of the string to the table. And your challenge to the kids is they have to make the paper clip come up off the table without touching it. So there you go. So you can let them, tell them to use their science superpowers and that they have to get that paper clip to levitate off the table, but they're not allowed to touch it. And just let them stay busy for a little while. They'll get frustrated pretty quick. And then what I would recommend is your after-school science kits have some circular magnets. I would not let them see you, but tape some to your hand. I wouldn't use masking tape. And don't cover the entire surface of the magnet with tape, because they're not really strong magnets. But then if you can kind of have it hidden in your hand, you can come by, make sure they can see that you didn't touch it, and come by and kind of trick them into doing it. And they're going to want to know really quick, how did you do it? So then you talk about magnets and what magnets can do, but kind of play the party trick on them here. So let me pass out some magnetic wands for now. So you can play with it. You can give them either one of these circular magnets or a magnetic wand. I believe your kit only comes with the circular magnets. You need to watch the little ones, because they will put things in their mouths. but these have a circle in the middle, so you don't have to be overly concerned, because if they did swallow it, I don't believe it would block up their air supply. I don't think they could swallow it. I think it's really a little bit too big, but they say that they can swallow a quarter, and that's about the size of a quarter. So I just wanted to let you know to watch them. So I'll let you use that bar magnet, and then I'm also going to give you a couple of the ring magnets that you'll get in your kit. You can practice cupping it in your hand or taping it. Trying to do it now before you do it with the kids.
Does a kit come with this?
Yeah, I think you get one of these Kids Science. Do y'all have one of these? No. You have a magnet kit. Do y'all have any magnets to work with? Okay. Okay. Well, I got the impression that all the sites had one of those kits, because that's what these curriculum units are written using, stuff that's in that kit. So, yeah. You could ask someone from CASE before you leave today. I know Trina Finley's not here today, but there's someone there. But try to kind of practice doing the magic trick part real quick so that you'll be real adept when you do it with the kids.
Do you need both magnets or just one?
I used two because when I did it with one, it wasn't quite strong enough. I had to get too close to they couldn't see it jump into my hand because I got so close you couldn't see it. So that's why I did it with two.
That would be awesome if they rewarded us with one of those kits for being known to.
Yeah.
I would like that.
So you also got a copy when you signed in of the Texas science standards that were associated with this kit. I know you're not classroom teachers, so talking about the TEKS may not mean a whole lot to you, but this tells you, tells you which of the science standards that you're covering when you teach. It's for everything that we're doing all day, all in one chart here. But basically, how we teach magnets and magnetism is a little bit different than we used to. So I wanted to let you kind of wrap your head around that. We used to teach magnetism was a physical property. Some things were attracted to magnets and other things weren't, which is still true. But now the focus is that magnetism is a force, because the kids weren't making the connection. And does anyone know how we would define a force, like in elementary school?
When you apply pressure to something? Or?
That's a force. Okay. A force causes things to move. You have to push it or pull it. A force, we say, like to a second grader, is a push or a pull. And so most forces they come into contact with are ones that they physically have to touch. If I want to move this little can, it's not going to move unless I push it or pull it. I have to touch it. But in space, you don't have to touch things to make them move. That gravity is a force that keeps things in motion, but for gravity to work, you don't really have to touch something. It's going to pull down and eventually hit whatever's in the way, but if it could keep going, it would go to the center of the earth. There's just stuff in the way. So you're not actually touching like the origin of where the gravity is. And the same is true for magnets. Magnets are pretty weird when you think about it. You can push and pull things without touching them. So I would kind of introduce it. I'm moving things around from your curriculum a little bit. Introduce it with this challenge and a little trick where you kind of trick them into, they're going to figure it out pretty quick, but it's still kind of fun to mess with their minds at the beginning of something. And what that does is it gets them engaged. Oh, I want to know more about this because that looks like it's fun. And so the first activity that you do with your lessons is to send the kids on a scavenger hunt. So you can send them around with these little round magnets if you have them, or I don't know, maybe teachers. I'm happy to send you home with one of these bar magnets today because I have a whole drawer full of them. Okay, so feel free to take the little red one you have with you. I don't want you to leave with nothing to use. But you have them do a magnet scavenger hunt. And you have a chart in your supplemental materials. It's on the very back page of that additional resources, page 26. or it's on page 25 actually, the chart. So they write down the name of an object, and then they put, I guess, a check mark if it's attracted to the magnet or not attracted to the magnet. So you can send them around looking for things that are magnetic. These little round magnets and these bar magnets are really not very strong, but you're not going to do damage to things that are around the school, but you still need to give them the lesson about things you don't go near with a magnet, because they may have a stronger magnet at home and decide to do a scavenger hunt at home and wipe out their parents' hard drive on their computer. So it's always wise to teach them there are certain things you don't go near with a magnet, even though this one won't do anything. That you don't go near computers, you don't go near anything that's electronic, you don't want it to go near maybe a credit card or someone's phone or someone's iPod. You just don't go close to electronic things with a magnet. I'm telling you that I could put all these magnets in my purse and it's not going to hurt my cell phone, but there are some super strong magnets that are teeny tiny that you get them close to something like that and you're going to wipe all the electronic information off of it. So it's just a real good idea to teach them sort of, not really safety issues, but I guess their own safety. If they wipe their computer's hard drive at home, they're going to get in trouble. So see how you made it move without touching it. So that's why magnets are really pretty interesting. So it suggests having the kids work in groups to go around for that magnetic scavenger hunt. My advice may be to bring some things from home, and actually you can have them start with a bag of objects and let them do this, and maybe then send them out, because they may have a better idea of what's magnetic and what's not magnetic. Kids innately know stuff about magnets. We don't really have to teach them. They have a refrigerator at home, they have magnets, they know stuff will stick to the refrigerator. I can remember when my own daughter was, gosh, she was little, less than 2, and she was crying, screaming, and she was just mad, and she was slapping the refrigerator. I'm like, what are you doing? She was trying to get a quarter to stick to it. And she's like, she already knew if something's made of metal, it's supposed to stick to that refrigerator, and no one had to teach her that, just inductive reasoning. And she was very mad when she couldn't get it to stick. And so that's a misconception you have to overcome when you're teaching about magnets. They think that because it's made of metal, that it has to be magnetic. And that is not always the case. So I have a little bag of different objects, and you can use either one of your magnets to try to, first, let's make it a little more scientific, try to put them into 2 piles. One pile that you think the magnet will stick to, and one pile that you think it won't. That's called predicting. Don't have to write it down, it's okay. But then I want you to then test it with the magnet. See if your prediction was right. That brings up another important point in science, is that there's not a value judgment to your prediction. It's okay if your data doesn't support what you thought would happen. Kids as young as kindergarten will want to change their prediction or change their hypothesis to make it right. And you have to very carefully teach them, it doesn't matter whether you think it's right or not. Could you evaluate it? Do you know at the end of the experiment, do you know whether your prediction was supported by the data or not? So, anyone surprised by some of the objects?
I don't know why I thought a penny was made.
It's because it's made of metal. So I deliberately put things that were made of metal that are not magnetic in the bag. So this isn't just a random assortment. They're very carefully selected. Some of them are pretty easy. You know, you have enough everyday knowledge of magnets to know that a wooden block or rubber band or a feather are not going to be magnetic. What surprised you probably was the money. Mm-hmm. And was there some other metal object that wouldn't stick? Those little brads that you hold papers together. Some of you may have had pieces of aluminum foil. Over time, these